Okay, so if you remember, it was 1 gram of sodium chloride that I weighed out just right before class. Okay. And I decided to dissolve it, and the number that I came up with was about 300 milliliters, and my solvent was water, okay, distilled water. Distilled water. Make sure you label everything in a lab, okay, for those of you that want to work in a lab. Okay. And I dissolved it in 300 milliliters of distilled water. Okay. So I've created a solution, didn't I? Okay, here it is. Okay, it's inside this bottle. All right, the solute, as we mentioned before, is sodium chloride. Okay, what is our solvent? Yep, 300 milliliters of water, and this is what I've made. Okay. So can I just leave it here and go home and stuff and dismiss class? Okay, so a couple of things here. First, I can't leave and dismiss this because, first of all, this is unlabeled. Okay, people freak out. Okay, especially if this is a lab and, you know, other coworkers. Tiana, do you know Miss Tiana? Okay, somebody in the Gen Chem 2 lab left something like this. This is true, last week. And, no, it was the biochem lab, actually. Okay, it left something out, just like that. It was a beaker. And there's a big freak out, like, what is that? You know, where do I dump it? Do I dump it down the sink? What is this? Is this a nasty chemical? Is this something dangerous? So we always label our chemicals. We always label our solutions. If you work in a real lab, the lab will get, you know, fined or something. Okay? So we need to label this, and we need to label it with a concentration. Okay? We need to label it with a concentration. This tells us how concentrated the solute is in our solvent. Okay? So we need to label this with a concentration. And here in chemistry, the concentration units that we use is molarity, okay? And it's big M. Okay, so this is an important term here, molarity. So this big M here stands for molarity. Okay. And something I'd like you to know for testing and whatever future. Molarity is moles of solute. In this example, it's sodium chloride, okay, over liters of solution. Okay. Okay, so that's the exact definition. Okay, very exact. Okay. You can say moles over liter, but really this is This is what I want you to know. Okay, moles of solute over liters of solution. So I weighed out 1 gram right before class. I dissolved it in 300 mils of water. And now I want to figure out the concentration of this bottle, of this solution that I just made. Okay? So let's go ahead and do that. Let us first convert this 1 grams of sodium chloride into moles of sodium chloride. Okay? So let's do that here. 1 gram of NaCl. I don't think I have my periodic table with me. Oh, I do. Okay, so let's convert this to moles. 1 mole of sodium chloride contains how many grams? You remember how we do this? Okay. Na is about 23.01 or 22.990. I'll say 23.01. Okay, what is Cl? Cl is 35.45. About 58.46 grams. So what's 1 gram divided by 58.46 grams? This gram and those grams cancel, leaving you with moles of NaCl. 1 divided by 58.46, what do you guys get? 0.017. Okay, yep, you're right. Thank you. 0.0171 moles of sodium chloride. Okay. And then what is the liters of solution then? Okay, I put it in 300 mLs, you remember? Okay, you saw that little demo. Okay, 300 mLs. So what is 300 mLs in liters? Okay, you're going to divide by 1,000. Do you remember this? So finally, the molarity, my final concentration of this bottle that we just made together as a class, the molarity, the concentration of this sodium chloride solution is going to be 0.0171 moles of NaCl divided by 0.300 liters NaCl. And what is that on our calculator? 0.057? Is that what you guys are getting? And this is what we want to put in our bottle. Okay? 0.057 molar. How do we call this? Or what do we call this? Okay, we call this molar. Molar. 0.057 molar. All right, have any tape? There's no tape. Oh. Okay. All right, and I label and date anything that I make, okay? So I put my initials and I date it. What's today's date?
October 1st.
The 1st of October, 2024. Okay, there you have it, okay? Okay. So label and date. Okay, so I initial it because the person knows, let's say our lab coordinator, Ms. Tiana, comes and sees this. First of all, now it's labeled. She'll look and sees that I made it. Somebody made it, VCA. Now, those are my initials. Any coworker or any student or anybody in the lab will know when it was made. I made it October 1st. And then they'll know that this is 0.057 molar. Okay, 0.057 molar NaCl. We label this, okay? Always label our solutions. All right. Any questions on this? Okay, how do we say this? Do we say 0.057 moles? Okay. No, do not say 0.057 moles. That is wrong. Okay, so this is a common mistake I see, okay? This is a common mistake that I see. That is not this, okay? What this is actually 0.057 moles of NaCl divided by liter of solution. So that's what this big M symbolizes. It's actually right here, okay? Moles over liter. Okay, so this is the concentration. Okay, concentration. How concentrated this is. How concentrated this is. You do this in your kitchen anytime you put some powder into water, okay, or vitamin C powder or sugar or salt or anything in water. Basically, you're just putting a certain concentration. If I add more solute, will I get more concentrated? Yes. Okay. If I add more water, will I get more concentrated? More water. More concentrated, or would I get more dilute? Yes. Okay, you'll get more dilute. If I add water, will my concentration be more than 0.057, or will it be less than 0.057? Less. Less. Okay, it will be less than 0.057. So this is how we do it. Okay, it's moles over liter. And what is this big M called? Molarity. We can also call it molar. So let me make this as simple as I can be. You take some powder, dissolve it in some water, you get a concentration. Okay? And here in chemistry, that concentration is molar, which is nothing more than moles over liter. Or that concentration can be also termed molarity. Molarity, which is the same thing, again, as moles over liter. This is not moles. Okay, this is not moles. It's moles over liter. So this is a common mistake we see a lot here. If you ever go to our prep room, there's a big blue cabinet. It's supposed to be like fire resistant. If there's a big explosion or something terrible happens, that big blue cabinet will stay safe. Okay, well, it's supposed to be indestructible. So inside we have some acids. Okay, we have very concentrated acids. Not only sulfuric acid is there, but hydrochloric acid is there and other things. So if you look at that, the sulfuric acid can be up to 18.8 molar. Okay, that is so concentrated. Okay, that could you literally see the smoke coming out. You have to use the fume hood. Okay, it will burn your nostrils. Okay, so we keep it in that blue cabinet. If you see our prep room, I can show it to you if you want to see it. Okay. A bunch of acids, not just sulfuric acid, okay, hydrochloric acid, nitric acid, and so on. Okay. All right. Let's do some problems here. All right, molarity. Okay, so molarity, two things I want you guys to know, big M and moles over liter. Moles of solute over liters of solution. Okay, what is the molarity of 85 milliliters of ethanol solution containing 1.77 grams of ethanol? Okay, so we will take that 1.77 grams of ethanol, convert it to moles, and divide it by liters. What is this in liters? 0.085. No. You move it 3. 85 divided by 1,000. What is that? 0.8. Yep. Okay. All right, so 1.77 grams of ethanol. Okay, how many grams are in 1 mole of ethanol? Carbon is about 12.01. So it's 12.01 times 2. Correct. Hydrogen is 5. What is hydrogen actually? It's about 1.01. What is that times 5? 5.5. Oxygen is about 16, right? 16.01. And then we got another hydrogen sticking out on the end there. So if I add these, So if I add these 4 numbers, what do I get? .46 something or so, 46.09. Again, your numbers may be a little bit higher, a little bit lower. Okay. So 1 mole of ethanol is about 46.09 grams of ethanol. So what's 1.77 divided by 46.09? Again, 0.0384 moles. Okay, of this ethanol. Okay, just double check my calculations for those that have a calculator. And then I'm going to take those moles and divide it by liters. Okay, so my final answer, molarity, molar, okay, is 0.0384 moles divided by 0.085 liters. And what do you guys get when you do that? 0.45 molar. This is what I'm getting, so. Big M. So this is our answer. Okay. That's the concentration of ethanol in moles over liter. So this is like, this is definitely, of all the, if I were to say, of all the things in this course, this is the section, these last 2 pages are the ones you'll see a lot if you go into the workforce, even in the forensics labs or whatever. Okay, you have to make solutions and you got to make them in the right concentrations. So this is the one that has most practicality. All right, can I move on? Moles over liter. Moles over liter is called the concentration. It's also called molar. It's also called molarity. All right, what volume in milliliters of a 0.315 molar solution contains 6.22 grams of sodium hydroxide NaOH? Okay, how will we do this problem here? Okay, it's asking for a volume. Okay, so let's solve for our volume. So we start with 6.22 grams of NaOH. All right, I'm going to go ahead and convert that to moles of NaOH. So 1 mole of NaOH contains how many grams of NaOH? You know how to do this? Okay, sodium, 23.01. Oxygen, 16.01. Hydrogen, 1.01. So 40. So 1 mole of NaOH is about 40.02 grams. Okay. So take the number, that bottom number in the periodic table, the decimal number, and add them up. Okay, the concentration here is 0.315 molar, which is what? Moles over liter. moles over liter. Okay, 0.315 moles of NaOH, okay, over liter. That's what this is. Okay. All right. I just flipped it to cancel out the units. And then finally, how do I get this to milliliters? 1 liter is 1,000 mLs. So moles over liter. Okay, but I made it liter over moles so that this mole and this mole can cancel, this gram and this gram can cancel, this liter and this liter can cancel, and I'm left with mLs, milliliters. So what is this on our calculator? 6.22 times 1,000. Divided by 40.02, parentheses 40.02 times 0.315. $493 mLs is what I'm getting. Okay. Okay. This is our answer. So what does this mean? Okay. What does this mean? This answer 493 mLs. So let me try to draw this out for you. Let me draw you a picture. So we have a bottle just like this. Okay. Instead of 0.057 NaCl, it's 0.315 NaOH. So here's our bottle. And it's 0.315 molar NaOH. I take out, okay, if I take out 493 mLs, how much NaOH did I take out in grams? 6.22. Okay, so I take out 493 mils is the equivalent of taking out 6.22 grams in here. Okay. If I take out 493 mLs, it is the equivalent of taking out 6.22 grams. Is the equivalent of taking out 6.22 grams. So that's what this means. All right, are there any questions on this? This is called solution stoichiometry, okay? Manipulating and playing around with the solutions. Okay, so all of these problems and all of the problems in your homework, chapter 4, they all involve solution stoichiometry. Also on your quiz has some problems with solution stoichiometry. Okay, once again, the key to solving these problems is moles over liter. Okay, what you need to do to get those units to cancel. let's move on to the last page of chapter 4. Okay. And another thing that you'll see in a practical sense, if you ever want to work in a lab, any type of lab, hospital lab, forensic lab, okay, chemistry lab, biology lab, okay, there comes a point where you're going to have to, instead of making things and weighing out the sodium chloride or weighing out your solute, why don't you just dilute it? Okay, dilute it from a stock that's already available. Okay, so this is called dilution. Dilution. So the equation for the dilution is M1V1 equals M2V2. Okay, M is molarity. Okay, V is the volume. Okay, M2 is the diluted solution. Bless you. And volume is the total volume. V2. Okay, we're going to call this the stock. Okay, the stock. Okay, and V1 is how much you take out from the stock. How much to take out of stock. So if we dilute this, okay, are we going to get a higher or lower concentration? Lower. Okay. So let's make a new solution then. Okay. How much do you want to make? How much? Give me a number.
0.85 grams.
A volume. Give me a volume. 400 milliliters. Okay. So we'll make 400 milliliters. So the first thing is, if we want to make a solution, okay, we want to know how much. How much you're going to make. So Gerardo, how much do you want to make? 400 milliliters. Okay, how much? Okay, to make a diluted solution. The second thing is, what is the concentration that you want to make? Okay, so we'll make 400 milliliters. And what concentration do you want to make, Gerardo? Now, can the concentration you want to make, can it be more than 0.057 or less than 0.057? Be more than 0.057 or less than 0.057? It has to be less. Okay, it has to be less. Can you imagine if this was glass? This would have been a disaster right here. Okay, complete disaster. Okay. So, give me a number less than 0.057. Has to be less. Less than 0.057, and you say 1.000. But we made a 0.057. So I'm saying give me a number less than 0.057. Hmm? Almost half, 0.036, okay? So we will make 0.036 molar. Okay, why did I say this has to be less than 0.057? Why? Right, you cannot produce more. All you can do is take this solution and make it less concentrated by doing what? Adding what? Adding solvent, in this case water. Okay, this is the very essence of dilution. Okay, this is the very essence of this equation. Okay, adding water to make this less than what it is because you need it. Okay, you need it dilute. We're going to call this the stock. Okay, this is called the stock. From this stock, I'm going to get 0.036 molar. And how much are we going to make? 400. Okay. From this stock, this is called a stock. I don't want to weigh out NaCl. I don't want to weigh out this again. Okay. I don't want to weigh it out. Okay. I have already a solution, and I am going to dilute it to what I want, which is 400, 0.036. Okay, do you realize it cannot be more than 0.05? Okay, because my stock that I have already made is 0.05 NaCl. Okay, we just made this the very first thing in class. Okay, we took 1 gram and dissolved it in 300 mils water. Okay. So we are going to make 400 mLs of a 0.036 molar solution of NaCl. Okay, so we are going to make 400 mLs, that's the volume, of a 0.036 molar solution of sodium chloride. So the equation we're going to use is this one here. Okay, M1V1 equals M2V2. Okay, this is a good equation to memorize. Just even the nursing majors, future nurses will do this. Okay, they use this. I know this because there's a nursing person at Fort Liberty, and he told me he works with us, and he told me that he made that solution through this equation. Okay, because I had to make some solution. Okay, so everybody uses this. Everybody. Okay, please understand this. Everybody uses it. This is an important equation. Okay, so this is what we're going to make. So we'll use M1V1 equals M2V2. Okay, so what is M1 here? Is it going to be our stock, or is it going to be the diluted one that we want to make? Okay, the stock, it turns out, once again, from the very beginning of class, is 0.057 moles over liter. Okay, 0.057 moles over liter. V1, and then M2 is 0.036, and what's V2? 400 mLs. Okay. So let's solve for V1. 0.036 big M times 400 milliliters. Okay, divided by 0.057 big M. This is our V1. So I want you guys to recognize the big M's and big M's cancel. So we are left with what concentration? Or what units, I'm sorry? Milliliters, okay. It's hard for you guys as students to learn if I keep saying the wrong things. Okay, the units cancel, leaving us with milliliters, okay, milliliters. So 0.036 times 400.
I got
252? 252.6. Let's make it 253. Okay. I don't think I can get 0.6 out of this. So whoever said that. Okay. So 256 milliliters of 0.057 NaCl. Okay. Is this our answer? Okay. This is not our answer. Okay. How much, what next? Or how much of water do we need to add? Take that away from 400. Very good, David. And 144 milliliters of water. Okay. This is the answer. This is how much water we add to 256 mils of this. So this is a tough one. I don't think I can get 256 out of this. I'll try. Okay.
You said we take out the 256 from the 400 milliliters, right?
Right. I'm going to take 256 from my stock. Okay. 256 from my stock. Okay, here's my stock. About 256. Okay, 256 from my stock. I took 256 here. We made 300, if you remember from the very first minutes of class. We actually made 300 mils. So we had 300 mils. So I took 256 from here. And then I'm going to fill it up to 400 mils of water, okay? Which is nothing more than adding 144 mils of water. So I'm going to fill this up to 400. Actually, I need a bit like this. $256 is kind of hard to measure on this one. Okay, now I have 144 mils of water, and that basically means I have a total volume of 400, so I'll just fill this up to 400 because we wanted to make 400. And we've made a new solution, and what is its concentration? 0.036, okay. Just a little bit more. So we made that solution. What I like to do is I like to take some parafilm tape and I mix it up. So you always want to mix things. Some parafilm tape. Do a little mix, a little swirl. And we made a new diluted solution. Okay. we could put it in our container, and we always label an initial and date. Okay. So let me do this. Bear with me. All right. So you guys tell me what the label should be. Okay. This is David decided to make a 0.036 molar solution of NaCl. Point 036 molar of NaCl. And how much did we make? 400 milliliters. And initial and date. Okay, so you can say I made 400 mLs if you want. There we go. Okay. So here is my stock that we made 300 milliliters of at the very beginning of class, 1 gram and 300 mils of water. And I took, how much? I took 256 from here. I took 144 of water from here. I put them into a new container. I did a good mixing, and here we go. Okay, we made a new diluted solution from our stock. Okay, from our stock. Okay, so this is how we dilute solutions. Okay, you just add water, and we get our concentration down to the concentration that we want. We make sure we want to know how much we want to make in the first place. Right. All right, so the equation here is M1V1 equals M2V2. All right, let's do some practice problems here. All right, how will you guys make 500 mLs of a 0.25 molar solution of magnesium chloride if you have a solution that is 1 molar magnesium chloride? Okay, so which one of these is our stock? The 1 molar magnesium chloride is our stock solution. And we want to make 500 milliliters of 0.25 moles over liter. So M1V1 equals M2V2. Our stock is 1 molar. Okay, what is M2? 0.25 moles over liter. And how much do we want to make total volume? Okay, 500 mLs. All right, so V1 is going to equal to 0.25 times 500. Divided by 1 molar. Bless you. Okay, the big M and big M cancels. 0.25 times 500, what is that? 125. Okay, so this is not the answer you'll give on the test. You'll say 125 milliliters of 1 molar magnesium chloride plus how many mils of water? 375 mils of water. Okay, you pour it all into a separate container. 325, 375, and that's it. Okay, date and label. Date and label. Okay, this is the answer. All right, how will you make a solution of 0.5 molar calcium chloride when in the lab there's a solution of 2.5 big M? Okay, so we need to find a volume. So let's make, how much do you want to make? much do you guys want to make? Okay, let's make 500 mLs. Okay. So making 500 mL, so you need a total volume, okay, kind of like at the very beginning. You need to know how much. Okay, so let us make 500 mLs of 0.5 molar calcium chloride. How will you make a solution of 0.5 molar calcium chloride? Okay, we need to know how much, so I just said 500 mLs. Alright, so our stock is 2.5 molar. How much from that do we take out? We want to make our final bottle is 0.5 molar, and we want to make, though it didn't say in the problem, but I'm going to say let's make 500 mLs. And what is that on our calculator? 0.5 times 500 is 250. What's 250 divided by 2.5? 100. Okay. So this is 100 mLs. Okay, this is not our answer. Okay, what is our answer? Okay, our answer is 100 mLs of 2.5 molar calcium chloride. Okay, plus how much water? 400 mLs of distilled water. So on the exam, you want to tell us how much water you're putting in. Alright, our last problem here, and that will finish this chapter. Okay. And then I think I'll take maybe 10 minutes or so, just 10 minutes to talk about chapter 5, which is the gas laws. Ready? All right, last one. All right, our last problem for this chapter. Okay, how would you prepare a 2 times 10 to the 3 mils? Okay, 2,000 mLs of 0.866 molar sodium hydroxide solution, starting with a 5.07 molar stock solution. Okay, so how will we prepare 2,000 mils of 0.866 molar NaOH, and our stock is 5.07. Okay, so this should be straightforward. Okay, M1V1 equals M2V2. So M1 here is our stock, which is 5.07 big M. Okay, V1 is how much we want to take out from our stock. And how much are we making? 2,000 mLs, 2 times 10 to the 3. And the final concentration in those 2,000 ml total volume is 0.866 molar. .866 molar, 2,000 mLs divided by 5.07 big M. Okay, big M cancels out. What do you guys get when you do this on your calculator? 341. All right, thank you. 341 mLs. Okay. So this is not the answer you want to put on the exam. You want to add a little bit more explanation. So what you'll say is you take 341 mLs from or out of the 5.07 molar stock of NaOH, and to that add how much water? How much water do we add? And add 2,000 mils of water. 1,659 sounds right, yeah. Yep, 1,659 mils of water. Okay, very good. Okay, nice job back there. Okay. And this is our answer. Okay. So dilutions, okay, concentrations, dilutions, moles over liter, and diluting things from our stock solution. So before I let you guys go, let me lecture just for 10 minutes, okay, on gases. And for that, you can just relax for a couple of minutes. This next chapter is totally based on gases. So what I'm going to do to explain to you gas laws is to cut an onion. Okay, so let's cut an onion. I'll cut the onion. You guys don't cut it.